Welcome back, reinforcement learning. This session I explained the reinforce algorithm. The reinforce algorithm is one of the fundamental reinforcement algorithm. It is based on training the model on policy based reinforcement learning algorithms. It is based on the uh, policy of the policy based reinforcement learning model. It is based on the Monte Carlo based policy gradient approach. It follows the approach of the Monte Carlo based approach sample. Okay, it is a trial and error type of method. Okay, in reinforcement learning algorithm, in this session I explained what are the key concepts in reinforce algorithm, how to implement reinforcement algorithm. In key concepts, we are using in implementation policy network and action, how to select the actions and how to interact the environment and how to calculate the reward and how to train the loop. Okay, these are the five key concepts we are using in reinforcement algorithm. In first one is the policy network. How to build the policy network based on the what are the input is required, how to what is the output of the network. In policy, in reinforced algorithm, we are give the input is state of the environment, and output is actions probability. Okay, in cart pole environment, we have the two actions, the left move or right move. We are indicate with the actions 0 or 1. Okay, here it gives the state is the input to the policy network, and output is actions probability, here 0.25 and 0.75. These are indicate the action 0 and action 1 correspondingly left move and right move. And this is the policy network. We implement the policy network using state is the input, output is probability distribution function. Next, action selection. Okay, we are select the actions based on the probability distribution of the actions. We are using np dot random dot choice function to select the sample of the action. The next one is environment interaction. How to interact with the game environment by using step method. We in last session explained the step method. The step method gives the 4 parameters as a output. It is a reward, state and done flag and info flag. Okay, we are using step method to interact with the environment with the actions. And reward calculation, we calculate the rewards. It is a very important to calculate the rewards. We are calculate the rewards is by using discount factor. Okay, discount factor, we calculate the entire episode rewards. And we apply the gradation based on that reward calculation. We calculate the loss of the loss function and apply the gradient to optimize the policy network. And next, training loop. We train the model using collected states and actions and rewards in entire episode. Okay, based on entire episode information, we train the model to optimize the policy network. These are the 5 concepts we are using in reinforced algorithm. In implementation, the first step is we need some environment. The first one, initialize the environment. How to initialize the environment? Using OpenAI Gym, we are using to implement the reinforcement algorithms on different environments. OpenAI Gym has a lot of environments. We are using any environment for our model to check our model performance. In this example, we are using cart follow model. Okay, we initialize the model by using the object name env is equal to gym.make environment name. Okay, using this gym.make method, we initialize the environment. The next one is setting up the policy network. Okay, what are the input state, what are the outputs based on our environment. We are using cart polo environment. The cart polo environment has the 2 actions. So based on the 2 actions, the output is 2. The input is in cart polo environment, we have the 4 parameters we are using in input state. So here model implementation using tosh.nn we are using for implement the policy network. It has the 2 layers. The one is sequential layer, the 4 inputs, 150 outputs, and we are using leaky ReLU activation function. And the next one is it has the linear is 150. The output is 2. The actions of card polo game is either left move or right move. So 2. The output is probability distribution function. So we are using softmax function for probability distribution. Using this code, we are implementing the policy network for card polar game. Next, setting up of the policy network. In this, we are using Adam optimizer and learning rate is 0.0009. In training, we are using this learning rate and Adam optimizer. Next, interacting with the environment. How to interact with the game environment using sample action collection and step method. Okay, we are apply the sample action collection by using np.random.choice of the actions. Here the actions either left move or right move. And before action, we reset the environment by using reset method, and after that action choosing, we apply the step method, step action. Okay, we are apply the action on that environment. It give the output is either produce the output in 4 parameters: state, reward, done, and info. State is the next state information. Action is what action we are applied on the current state. The reward is immediate reward, and done is the boolean indicating flag the episode has ended or not. The info is diagnostic information. Okay, we are not using all cases the info parameter. So the step method by applying the action of the environment, it gives the 4 parameters output: state, reward, done flag, and info. Okay, in this code we are interact with the environment. After that, we train the model based on the entire episode rewards. Based on entire episode rewards, we calculate the loss function. Based on the loss function, we apply the gradient to optimize the policy network of the network parameters. So in training the policy network, we first calculate the loss function. Okay, we are calculate the loss by in reinforced algorithm is based on the negative log probability of the actions taken weighted by the discount returns. Okay, we are calculate the loss using negative log probability, and this loss function ensures that the actions with higher rewards increase in probability. The loss the actions with lower rewards decreases in probability of the actions. Okay, using that we calculate the loss function. After loss function, we compute the discount rewards of the entire episode of the loop, and we calculate the discount factor and normalize the loss values in certain range of the values. This is ensure the efficiency of the learning. Otherwise, the noise is occurred in learning process. So we must apply the normalization. In full training loop, this is the full training loop. We have the number of epochs we are taking, and we have take the number of episodes, means it is the number of times we reach the initial state to target state. Episode means the traveling from initial state to ending state is the episode. So how many episodes we have? We mentioned the episodes and the gamma value, discount factor value, and what are the optimizer we are using, and we set the model. After that, we collect the rewards, state, actions, information from the episodes, and based on that information we calculate the loss, and we apply the gradient and to optimize the policy network to get the best rewards, best cumulative rewards. In this way we are trying the loop. This loop has an initialization, reset the environment, and start the new episode and collect the transaction. Transaction means by using step method you collect the information of the actions and the rewards of the states. Based on that we calculate the discount rewards. Means that is the considerable earlier rewards are based on the future rewards. Then next calculate the loss based on the collected information by using log probability, and apply that gradient on the loss function with respect to weights parameters of the policy network. Okay, this is the reinforced algorithm implementation. After the reinforcement algorithm implementation, we are initialize the environment and collect the transitions from the environment and calculate the discount rewards and compute the loss and back propagation to optimize the policy network to get the best cumulative rewards. The reinforce algorithm is we can apply in simple problems. It is not suitable for the complex environments. It is suitable for the simple environments. If you are working with some complex environment, we require some more advanced methods in reinforcement algorithm. In the small simple applications, simple environments, we are using reinforce algorithm to learn to optimize the policy network. Thank you.